Thank you, Tara, for giving the audience a glimpse of the journey we are on to normalize a culture of innovation and change in the Transportation Cabinet. Our next speaker is Atorod Azizinamini. He is the Director of Infrastructure Research and Innovation at Florida International University and Vasant Surti Professor of Civil Engineering. Atorod is also the Director of the Accelerated Bridge Construction University Transportation Center at FIU. He received his Bachelor's of Science with distinction from the University of Oklahoma and his Master's and PhD from the University of South Carolina. He worked for 5 years as a structural engineer and has carried out more than $60 million in research as principal investigator and has graduated more than 35 PhD students. His research activities have covered many aspects of structural engineering. Since 1995, he has focused on bridge engineering research and has received numerous awards, including receiving President Obama's White House Champion of Change. Something we can all strive for is to be a champion of change. Transportation Innovator Award, and in 2015, which was given to him in a ceremony at the White House. His hobbies include music, watching OU football, martial arts, and spending time with family. Please help me welcome Atorod to the stage.
Thank you for that kind introduction, especially mentioning that where I graduated with my bachelor degree. All right, it gives a great pleasure to be here. It's always a pleasure to be in Oklahoma, and it has a special place in my heart, really, the Oklahoma. And I always considered Oklahoma really a home, and because I was a teenager when I came here to get my bachelor degree. And I don't remember much about where I got my master and PhD, to be honest with you. So that's, I think, because when you're a teenager, when you come down here. All right. Before I just wanted to share with you who we are and so on. I used to be actually being a graduate of the OU and being a faculty at University of Nebraska-Lincoln. So you see how opposite of the spectrum I've always been. So I was a faculty there for a while. So then I went to FIU, and my mandate was to bring a federal center, basically a federal money to FIU, Florida International University in Miami. So in 2013, we got the Tier 1 University Transportation Center. We had 2 universities as a partner. Then in 2016, we again were successful to obtain another Tier 1 in the new competition. This time we added the University of Oklahoma and the University of Washington in Seattle as a member. And for the third time in 2023, we again received the funding for the Tier 1 that's going to go to 2029. And this time we added Texas A&M. I think your director is a graduate of Texas A&M, so I guess he'll be happy. And the University of Georgia and then the FAMU. So right now at the University Transportation Center, our objective this time is to bring the innovations into the bridge engineering. And it really, when Tara was talking about the innovations, and really, it's not by coincidence. It's the message that is being sent by the US DOT. It's a message that was sent by the bill that was signed by President Biden in November of the 2021. And it kind of trickled down in every agency. So I'm going to discuss that. So really the team over here, I'm going to share with you a few points that I'm very passionate. And it's not just me, but I think it's the way, if you want to get the bridge engineering back to the glory days and the transportation system, it's going to have to go through the innovations, through the technology. And so in order to do that, you know, sometimes I had one friend said that if you want to predict the future or you want to decide what you should be doing, it's not a bad idea. Stick your head out of the window, look at the past. And when you do that, you really, you come out with lots of good lessons. Now, this is a slide that you see. I put a couple of landmark bridge structures. You've got basically the Brooklyn Bridge, you've got the Golden Gate, Ed's Bridge in St. Louis. And these are the golden days of the bridge engineering in the US. I picked the Brooklyn Bridge really to elaborate and to kind of highlight some of the points that I would like to share with you. I will argue that the amount of the innovation that went into the design and the construction of the Brooklyn Bridge was unparalleled. And in fact, Joseph Strauss, who was the designer of the Golden Gate Bridge, he said, if the Brooklyn Bridge was not built, we could not have built the Golden Gate Bridge and many other bridges. And he was absolutely right, okay? The Brooklyn Bridge was designed by John Rubling. John Rubling was a German immigrant that came to the US, and his education was in the mathematics, hydraulics, and architecture. And in fact, he went to Pittsburgh and he wanted to have a community, and then he gave that one up, and then decided that to become a bridge engineer. And he built several, actually about five bridges actually, similar but very small scale before he took on the Brooklyn Bridge. And the story is that one day he was crossing basically from the Manhattan to the Brooklyn, and then the East River was frozen and he had to spend the night. And the idea of the building something like the Brooklyn Bridge came at that point. But at the time, when he decided, and he had lots of obstacles, when he decided to propose, and the Congress actually finally approved the building of the Brooklyn Bridge and the funding and so on, it would have been twice longer than any bridge of the time. The steel, in fact, he had a patent on a steel cable, and the steel was never used for the cables. So he tried to do that. The foundation of this Brooklyn Bridge, in order to do that, at that time, what they would do, basically, they would build these caissons, which is a very big box. The bottom is basically open, and then the sides were like a V shape. You just put a weight on the roof, and then you submerge it until you hit the bedrock, and then you fill it with the concrete and so on. So it was the largest one, much larger one than anything before. At the time, actually, the Ed's, who was the designer of the Ed's bridge in St. Louis, he was doing the same thing, but there was no communication. Lots of people at that time, they didn't know, for example, these are some of the challenges. They didn't know that, for example, they had to put a compressed air in order for the air, not the water to come in. But little they knew that compressed air, if you have that kind of condition, you have to come very slowly from there, depressurized, because otherwise you get a nitrogen bubbles in your bloodstream, and then that causes a paralysis and even death. 40 people died. So there were lots of challenges. But and another thing about the Brooklyn Bridge was the championship. Sometimes the innovations really requires to be a champion. When John Washington, actually, it was a very freak accident that he died on a side. One time he went to basically he was trying to inspect, and then his toe was cut in somewhere, and then he was of the opinion that with the water you can really cure everything. So he didn't listen to the doctors, and that actually caused his death. But then the same, in order to finish the design, his son, Washington Rubling, took over. And Washington Rubling got basically the bend disease, basically when the fact that when you come out of the pressurized chamber, you have to depressurize and all that. So he got sick and he was paralyzed. And in fact, in the Brooklyn side, he was living on the Brooklyn side, and then he had with the binoculars, actually, he was watching the progress of the construction, and his wife, Emily Washington, took over. So sometimes these innovations really takes a commitment, takes a championship in order to make it happen. And Roebling family, John Roebling, then the son, Washington Roebling, and then Washington Roebling's wife, Emily Roebling, they basically the champions. And you have to have a perseverance. And anytime you come up with the innovations, there's always a challenges. There's always a challenges that you have to really overcome. Now, I'm going to skip some of this point. And this bridge was really opened. Well, let me see if I could go back. Okay. I think there's a, okay. And, all right, here is it. So this family commitment really helped quite significant. The other thing I think you find out when you look at some of the bridges, like Joseph Strauss that designed the Golden Gate Bridge, or Roebling's, they were multidisciplinary. They did not just they were not just a bridge engineers. So, okay, you find these people, they were multi-talented. For example, John Roebling was a German immigrant. He studied mathematics, architecture, hydraulics. And the same thing goes with the other really very famous bridge engineers. And some of the lessons that we learn from the bridges, I thought this is not a bad idea to say. First of all, the maintenance. The maintenance was really, some of the bridges that have lasted more than 100 years. The biggest factor probably is because they are a historical landmark, and they have been maintained quite a bit. They've been adaptable to changes. Now, this is I want to elaborate on this. You know, one of the challenges we have right now, let's say 100 years from now, one of the challenges for long-term planning is that what technology is going to be a winner? What kind of bridges are we going to need in 100 years? My answer to that one is that we don't know. We don't know. The technology is changing so fast. Is it going to be a drone? Or going to be? I mean, there are initiatives right now from Kennedy Airport to the LaGuardia. Basically, it is like a drone that takes the people. Now, it's not going to replace everything, but it's going to address maybe 5% of the transportation issues. So, not knowing what technology is going to be the winning technology in the future, really, that has to come into our planning for the long term. That's why I think the preservations, trying to get the more juice out of the asset that we have, is very important, because there's no need to build, I think, in my opinion, that's my opinion, build a bridge that lasts 150 years. 100 years ago, did we know that what is going to be today? No. And the same thing 150 years from now with the way the technology going. So I think the preserving with the new materials and getting the more juice out of our infrastructure is a factor. Another thing that we learned from some of the bridges that have last more than 100 years is that they were originally over-designed. In the Brooklyn Bridge, actually the factor of safety was original for the cables. John Roebling designed it based on the factor of safety of the 8. Now, over the time, the factor of safety have come down, but it still is good enough to meet the current design conditions. And we're championed. Innovation needs a champion. So like Tara was saying, that it's very welcome to hear the Department of Transportation, they are looking at this. This is the first time you never heard that 10 years ago. Now I'm seeing in the different state DOTs, the collaboration between the universities and the state agencies are crucial. One of the things that as a society we have not really valued is promoting a good relationship between the universities and the state agency and the industries. I used to travel to Japan and South Korea for research collaboration. Down there, the industry and the university collaboration is much stronger than here, I can tell you. But right now, it seems like this collaboration is taking a different stage, and that is extremely important. You've got the brain powers in the universities, and you've got the brain powers in the state agency in different ways. And it's a combination of the two that's going to really result into the success. So while there were lots of innovations in the late 1800s, early 1900, the US, the bridge engineering in the US was absolutely #1 in the world. Many people would come to the US to learn from the John Rupling, from the Eds, and so on. But that leadership was lost, okay? And I want to elaborate a little bit on that, okay? There used to be, we talk about the accelerated bridge construction. There were many companies in the late 1800, early 1900 that they had a catalog, like a Sears catalog. They would go from the county to the county, and they would sell these bridges. All these truss bridges, for example, that you see, the Pratt and so on, it's the name of the people that they invented, they patented. And there was almost 800 patents during that period, okay? And it's something that we have to value. Look at the cell phones and everything else. How many patents do we have? And in different industries. I think we have to welcome the patent, the proprietary products. And the US DOT right now is very hot on that. So this is the history of the bridge engineering. That's what really caused the bridge engineering to strive to be absolute #1. This is a photo of one of the places. The salespeople would go to the different counties. They would say, very simple form. What do you want to do? You want to go from the point A to point B? Okay, this is a catalog. I have this kind of bridge. Once basically the handshake was given, they would go back, they prefabricate the bridge element, the trusses, and then ship it to the site and assemble it. So accelerated bridge construction existed back then. we did not invent it. It was there. So, and that's what I was saying. Patent, I think we have to overcome. For many different reasons, we have kind of shied away, but really that is the engine. That is the engine of the making of progress. And in fact, Thomas Jefferson was the champion of the patent. Originally, he didn't like it, but then he came across and actually he supported. And the Patent Act of 1790 basically said that if anyone comes up with a new idea, that the right of that person have to be preserved. Then something happened. This is where it came to the halt, to a stop. Something happened in 1976. My own feeling, if you ask me why, there was a Title 23 CFR 635 that came into the law that really prevented the proprietary solutions to be used in the bridge engineering. My own feeling is that the reason for that is because the 1968 Silver Spring Bridge in West Virginia collapsed. It was a backlash of that. In fact, that collapse in the West Virginia was the reason for was the initial basically point that now we are inspecting, rightfully so, every bridge once every 2 years. That's where it came from. But it took several years for the AASHTO, Congress mandated the AASHTO, US DOT, yet you have to come up with solutions so that this kind of collapse doesn't take place. That Silver Spring Bridge caused many people, more than 40 people died. It was in December